So, welcome back. We have been trying to understand the nuances of simple harmonic motion, which is a periodic motion, which has a frequency, which has a time period, which has an amplitude, okay, which has a displacement, which has a velocity, which has an acceleration associated with it, an acceleration which is proportional to the displacement itself, and it is always directed towards the mean position or the equilibrium position of a vibrating body. And one of the leading scientists and mathematicians of France in the 18th to 19th centuries, Jean-Baptiste Joseph Fourier, is a big name, and of course he did a lot of work on the simple harmonic oscillator, okay, where I said that it is F is equal to minus kx, or d2x upon dt2 is equal to minus omega square x, okay, that kind of function, right? So now let us see as to what he arrived at, Mr. Jean-Baptiste Joseph Fourier. I don't know if he was a professor anywhere or whatever, but he was a scientist and mathematician. And what he says, any periodic function can be expressed as a superposition of sine and cosine functions of different time periods with suitable coefficients. Superposition means you can impose one thing on the other and you get a new value. So that can be obtained by addition or subtraction of those two functions. And they are periodic functions, periodic in the sense that the function at time t is equal to function at a time t plus capital T, where capital T is the period, is equal to the function at t plus t, capital T plus capital T, which is 2t, etc. So we can write it as, okay, function of t plus minus nt, where n is an integer, okay, which means that, for example, if we try to define, like in the case of the reference circle that I made for you earlier, sine of theta is equal to sine of theta plus 2 pi is equal to sine of 2 pi theta plus 2 pi plus 2 pi. That means after 2 pi the value will become the original value. It's equal to sine of theta plus n 2 pi. And similarly for the cosine function. So I can write this as sine of theta plus n into 2 pi, etc., etc. Now let us take this theta is equal to omega t plus beta, where like our phi and alpha and delta, beta is an initial phase. It doesn't matter at all. We can write it ka, kha, ga, ga, whatever we like, alif, ba, ta, sa, whatever we like, symbols. So sine of omega t plus beta is equal to sine of omega t plus beta plus 2 pi is equal to sine of omega t plus beta plus 2 pi plus 2 pi, and becomes equal to sine of omega t plus beta plus n times 2 pi, etc., etc. n is r cosine, cosine, cosine. Okay, but beta is the initial phase. Initial means when I put in this function t is equal to 0, then it becomes sine of beta. T is equal to 0, sine of beta plus 2 pi, etc. etc. Okay, so it doesn't matter. Now, following some of the books, we will just check if these things are periodic or not. Do they follow Fourier or not? So in the first case, let's take A. Then what is the value of, this is the value of x, so x dot becomes equal to omega cos of omega t by the usual method. I will not try my method over here, plus, and because it is cosine, so it has to become minus omega sine of omega t. Okay, so x double dot, this becomes equal to omega into omega, and for cosine it is minus sine, so this is equal to minus omega square sine of omega t, and here minus omega square cos of omega t. So let us take minus omega square as common. So what I get is minus omega square sine of omega t plus cos of omega t. And what is this in the bracket? This is equal to x, so this is equal to minus omega square x. Okay, and therefore we can say that this function is definitely periodic function, is a solution to the equation x is equal to sine of omega t plus cos of omega t. So this is periodic, right? Similarly, I will try the B and write x dot easily as omega cos of omega t plus, but cosine when differentiated will give you minus sine, so minus 2 omega sine of omega t, like that, and x double dot, this is equal to minus omega square, okay, sine of omega t, I'm sorry, there is one more, plus 4 omega cos of 4 omega t. Okay, so this I can write omega square sine of minus omega square sine of omega t, and this I will write as 2 omega will multiply with that, sine will convert it into cosine, minus 2 omega whole square sine of 2, I'm sorry, cosine of 2 omega t, like this, minus 4 omega square, okay, sine of 4 omega whole square into sine of 4 omega t. Okay, so now I leave it to you to try and see if this is according to our value that we can get or not. Separately, of course, they are the solutions that we obtain. Now, if we take part C, what is part C? I'll just give an argument, e to the power of minus omega t. Imagine what happens to it. E is a number, okay. E is a number, 2.7 something, power minus omega t. So omega is defined, okay, is a constant, but as we increase t, so this value keeps on, omega t keeps on increasing and increasing, okay, and therefore there is no question of any periodicity. So this is aperiodic, this is not periodic. And similarly, in part D, let us try log of omega t. Again, let's see what is the argument. Log of omega t, when we write, then the base becomes equal to 10, okay, in general, or whatever base it is. But you can see that this omega t with time, this is something omega t in both cases, and this is the time t, and as we, so this also keeps on increasing and increasing and increasing and increasing. There is no question of a return to the original value, and therefore both these functions, they are aperiodic, they are not periodic, etc. Okay, we'll talk about it a little later. So friends, as I told you that in simple harmonic motion we have a solution for the displacement as a cos of omega t plus minus phi, a sine of omega t plus minus phi, any kind of a thing is there. And now I am going to bring in very basic definition of simple harmonic motion as it is introduced to kids. Okay. One thing about it is that it is a straight line motion. It is a straight line motion. It is periodic. It is to and fro, back and forth. And when it happens, then the three properties associated with the motion. One is the instantaneous displacement, instantaneous velocity, and instantaneous acceleration. And what kind of a relation exists over there? So here, let me take as the representative this thing, x is equal to a cos of omega t plus phi. And to keep the things within our control, within our understanding, we take the value of phi is equal to 0. No problem. Okay. We can take a value of phi, any value of phi, and then we are going to take the value of phi as equal to 0. This is the location which is called the equilibrium position. And you can see that my system oscillates between, on the x-axis, this is the origin of the x-axis, just like that. We can choose any origin, but we have taken it again for the sake of simplicity that x is equal to 0 is in the middle. At this extreme, the value of x is equal to plus a, and at this extreme, the value of a is x is minus a. Okay. Now, suppose the particle is undergoing simple harmonic motion. Let us take this position here, randomly chosen position. If I choose this random point over here, then we can say that the x is located here. And what is the direction of x? Direction of x is like this. from here to here. Whether the particle is going away from here or is coming close to it. For this position there are two values of velocity. One, when the particle is moving from left to right, and the other when the particle is moving from right to left. These two values are there. But the acceleration in both cases is towards the equilibrium position. X double dot is opposite to the value of x. So whether the particle is going from left to right or is coming back from right to left, in both the conditions x is the same and x double dot is the same. The only difference is that while the direction of x is away, positive over here, the value of x double dot is towards it, so it is a negative value. Okay. Like you say, I choose the point over here on the left hand side of this equilibrium position. X now it is in this direction. X dot, which is the velocity, could be in both the directions. The magnitude is the same at this point under consideration. Whether the particle is going left or the particle is going right. X double dot, in this case you can see that x is, the displacement is negative, and x double dot, it is positive. It is towards the center. Okay, so it is the kind of the equilibrium position seeking acceleration that we have in both the cases. Okay, always towards the center, towards the equilibrium position. Okay, now let us see that this equation is now written as x is equal to a cos of omega t. Okay, let us put t is equal to 0 in this equation. So a cos of 0 and cos of 0 is equal to 1, alike. Okay, like that. So t is equal to 0, so the value is here. And the location of the point, the oscillating point, the oscillator is at the right extreme at plus a. I have also shown to you that if t is equal to 0, omega t is also equal to 0. No problem. The value of velocity over here is equal to 0. Whether it has just arrived over here or it is just leaving this point, in both the conditions the x is equal to 0. X dot is equal to 0. We cannot say anything about the direction because the magnitude is equal to 0. So this is one situation. Now, if I look at it, then the total period means that it has moved like this back to this point, or like this back to this point, or like this back to this point, in the same condition of motion. The initial condition of motion is repeated after a time capital T, 2t, 3t, n into t, where n is an integer, as I have told you about. Okay. Now let us take, and what we are examining now is the position of the particle or the vibrating body after a time t by 4. Now t by 4 corresponds to omega t is equal to pi by 2, and here also this is pi by 2. Sometimes you are taken for a ride Once you commit one mistake, then you have to commit another and another and another. So everywhere here pi by 4, I will make it pi by 2, pi by 2, pi by 2. Okay, because t corresponds to what? T corresponds to 2 pi. So t by 4 will correspond to 2 pi upon 4, which is pi by 2 radians. Okay, so mistakes happen, no problem, but this is okay. So when t is equal to t by 4 and we get this as omega t becomes equal to pi by 2, then the cosine of pi by 2 is equal to cosine of 90 degrees is equal to 0. Okay. So this body will return to this position which has been shown here. At that moment of time, we'll see, and you can think that the velocity is maximum, but its direction is like this. The displacement is 0 and the acceleration is also equal to 0. Okay, of course. Then add another t by 4, so it becomes 2t by 4, and this comes to this position. And here again, the x dot becomes equal to 0. X is minus a, and x double dot is maximum and is directed towards the center. Another t by 4, that is t is equal to 3 times t by 4. Omega t is equal to, oh, what a nonsense. You can see this happens. Okay. If it happens with me, it can happen with you also. So don't worry. Okay. Make corrections. We are meant to make mistakes and then make corrections. So I stand corrected. No problem. So that way, now here at this extreme, left extreme, the velocity is equal to 0. The displacement is in this direction, negative. The acceleration in positive direction, it is maximum. Okay. So similarly, if we just go on adding t by 4, 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 pi by 2, pi by 2, pi by 2, pi by 2, then we get these positions, which you can draw yourself, and do draw that. Never think that I can just imagine that this is here and this will happen and this, that. No, not initially. Anyway, so I can show you that when there is no loss of energy, there cannot be any loss of energy, because this is the imagination. Okay. Now let me draw. It's not to the scale, but still it's not bad. I'm going to draw this x is equal to a cos of omega t as a function of time t, and the marcations are t by 4, 2t by 4, 3t by 4, 4t by 4, 5t by 4, etc. In some of the books they will write this as t by 2. They will write this as t. Nonsense. I don't subscribe to what they say, because it is a matter of the scale, and the scale enhances that way. 1, 2, 3, 4, 5 into t by 4, 6, 7, 8 into t by 4, like that. Then we find that the displacement, I'm just doing it for displacement, when the value of cos of omega t is equal to 1, thereafter it is 0, then thereafter it's minus 1, and then 0, and then 1, then minus, again this is 1 and this is 0, etc., etc. Okay, so this will go on. doesn't matter. If instead of taking the variable as t, the time, I take that variable as omega t, then in the blue ink I have pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 by pi by 2, etc., etc. in the same curve. Okay, so it has been expressed in two kinds of variables, t and omega t. Okay, there is no problem, not at all. Now in the graph that follows here, I have shown you two functions, x and x dash, and these two functions is not x dot, x prime, or I can take it x1 and x2, etc., where the amplitude has been a and b respectively. I have shown it, the first function like this with the continuous curve, and the second function with the dotted curve. And you can see that the nature of the two graphs are the associated time period, okay, is the same. Now, how to say the time period? So I need your attention. Suppose I talk about this point. Okay, let's trace the curve, and we see that this point is maximum with decreasing. So for the first time we get this point as maximum and decreasing. So it is the same, it is the same value, it is the same thing, and you can see that from here to here the time taken is equal to 4t by 4. Okay, no problem. See again, let's take this point, let's have a double this. Okay, this is zero crossing from positive to negative. We go like this, come back here. Okay, again that same zero crossing. So this is 5t by 4 minus t by 4. Again the value is 4t by 4, which is equal to t. Okay, but one of your friends is not a good person. He is not a good person. He says, I want to know as to what will happen to this point under consideration. Okay, young lady. Okay, so let's see. Again go down the curve. Okay, this is the position where you're coming from maximum to the zero value, decreasing. Then we go like this. No. Ah, I got it. So from here to here, it is again the time period. So the periodicity, the capital T is defined that if we have a time t, then let us look for a time t plus capital T. What happens to a time t plus capital T? That whatever is available at time t, the same thing is available at t plus capital T, also at t plus capital T plus capital T, also at t plus capital T plus capital T plus capital T plus capital T, etc. So I hope you understand how the time period is defined. And from the time period, we can also always find out what is the frequency. From that we can find out what is the omega. Okay. And what is required is, we must understand what is x, x dot, x double dot. Okay, these are some of the things. The amplitude, which is A here and B here, etc., etc. Okay. So this is how we try to understand. Of course, these values, you know what they are for. So I'm not going to tell you time and again, time and again, time and again, time and again. Okay. So this is about the simple harmonic motion, which we can obtain by several means. By several. The only thing is, what should be there? That the force must be equal to minus kx, or the acceleration should be equal to minus k upon m into x, which is equal to minus, this is the crux of the matter, omega square x. So omega square becomes equal to, it's very simple scribbling. So this is minus omega square x, omega square is equal to k upon m, omega is equal to under root k upon m. This is the kind of things which we need. So any time when we search for a motion, this is a simple harmonic motion, whether it is a simple pendulum, whether it is a spring and mass system, or whether it is any other system, okay, an oscillating boat, a platform oscillating like this, etc. Then the force has to be determined, and the force has to be shown that it is proportional to the displacement, and then this kind of a thing. This is the key to it, that the acceleration is proportional to the displacement. I'm sorry, this equation is wrong, absolutely wrong, idiotic on my part, and because I've written like this, so this should be like this. Okay, because one side is the vector and the other side is not, so there must be an idiot like me doing that, or even an idiot like you. Okay, so it doesn't matter. I don't call names to myself alone. Anybody doing that is an idiot of the highest order. Stupid. Okay? As I say that there is no sin other than stupidity. So friends, boys and girls, ladies and gentlemen, I have explained to you what is simple harmonic motion. I've written the name of the father of the simple harmonic motion here, Fourier, and I have told you that how a simple harmonic motion can be understood in terms of an equation of this kind: x is equal to a cos of omega t plus minus phi, x is equal to a sin of omega t plus minus phi, or delta, or alpha, or beta, or ka, or kha, or ga, anything you like. So, in the next outing, I will tell you more about the simple harmonic motion, and particularly about the energy associated with simple harmonic motion. Please come, revise with these lectures for the next lecture, because that is in continuity, okay, that you will be able to understand that thing. Thank you very much for today. Bye.